folks, welcome to another episode of Data Center Pulse focused on the chill-off. Today we're here to talk about the Liebert XDR solution, which is a product in the family of the Liebert XD solution, or system, really. And with me I've got Doug Werner. He's from, welcome. Good to see you again.
Thank you.
Yeah, Doug was heavily involved with Chill-Off 1 in the testing of the Liebert XDV solution. And Doug's from Emerson Network Power, the cooligy division here in Mountain View, right?
Right.
Okay, so he's going to take us through some of the compelling features of the XDR. We'll talk a little bit about how it differs from the XDV, and then just some of the flexibilities and that kind of thing.
Okay. Well, what we have here is, like you said, is the XDR. It's a rear door. It's a passive product with a 20 kilowatt rating. What we mean by a passive product is that we have no fans involved with this. As you can see, I have no electrical connections going into it. We have no fans moving the air. It's just relying on the server fans themselves.
Right, so the entire heat exchanger is built into this rear door, right?
Right.
Okay.
And so it's a 20 kilowatt capacity, and the way we designed this was to create a room neutral environment. What that means is if you have a data center which is typically around 72 degrees Fahrenheit, for example, air comes into the servers, heats up, but then goes through this rear door before going back out in the environment. And when it comes back out in the environment, it's at that same temperature as when it came in.
Okay, and that's actually an interesting topic. So containment. I mean, there's, for years now we've been talking about, do we contain the hot aisle? Do we contain the cold aisle? Your containment's basically built into the rack here.
That's right.
And not only does that simplify things in terms of we're not spending money on curtains or steel doors and false ceilings and that kind of a thing, but you've got the efficiencies inherent in a containment solution built right into the door.
Right, and you also have added flexibility because the air all around that space is basically room temperature. I don't have to be in a hot out, cold out configuration, so for some of the data centers that are maybe older and haven't gone all the way to the hot out, cold out configuration yet, but they're starting to get some new servers in that are higher power, this is a solution for them. They can actually use this to control that temperature in that environment and without having to do anything additional. The other nice thing about this is it opens up new configurations that might even be more energy efficient. So we traditionally had the hot out and cold out containment, or with or without containment. But now what you can do with this type of configuration is actually you can move the air from one side of your data center straight across to the other side, where the exit of one rack is the entrance to the next rack. Okay. And that's something that this product allows you to do.
Yeah, that's an interesting configuration too, because I know as we've gotten, over the last couple of years, we got away from doing something like that into the hot out, cold out, but it sounds like with this, you've got the ultimate flexibility. You could do either one, and there's also some benefits in that, right? In that if you had one feeding into the other and set them up on separate circuits, you could have some ride-through if you needed to take down part of the system for maintenance or if you had an outage. Almost some, I'll call it cheap redundancy.
Right, yeah. What you have, and that actually will work if you have a hot out, cold out configuration as well. But typically the way we would deploy these in the field would be connecting these doors up to alternating pump stations, for example. So it might be an AB or an ABC configuration. And by doing that, if you bring one system down, the air will still mix before going into the next one. So you're not just jetting really hot air into the next system. And so by doing that, what it does is it kind of gives you a built-in redundancy while you do take something down for maintenance.
Right, because if you got cold air coming out the back of the rack, I mean, that's perfectly fine to feed it right into the inlet of the next rack, right?
Right. What we've actually found in the chill-off was that the hot aisle was colder than what the entrance air was in the cold aisle.
Right.
And that's just because the air coming out was cold and then mixed with the different heat sources that are in the room that are part of the chill-off configuration, and it just mixes and then comes back in. But during testing, we found out that it's actually colder over here in the hot aisle.
Yeah, which is not a bad thing, right?
Absolutely not a bad thing.
That's funny.
And by having the room neutral environment, if you were to build a data center using this kind of configuration, the advantage is you're just trying to control the humidity in the room. So you don't need all the cracks and everything else that you would have for moving air. As long as there's an air supply going through the door, and because we're in room neutral conditions, you just make sure you maintain the humidity and everything else takes care of itself. So you don't need the number of cracks that you normally do.
Right, which is great. I mean, we've been driving away from cracks for a number of years now with the XD system as primary cooling in the room. It sounds like this just adds another tool to that toolbox of modular, close-coupled cooling. This one just also happens to be completely passive.
Right. With our products, we started out XD as a supplemental cooling solution.
Right.
Now our latest generation of products is enabling customers to use it as a primary cooling source.
Right. Well, thanks for the overview. I know this is very interesting to us just from a compatibility standpoint in that, like I said, at Sun, we've been using the XD solution or system for about the last 5 years now almost. And so the fact that this plugs right in and like I said, offers just yet another option either to get higher densities, greater efficiencies, you name it. It just sounds like very, very flexible, so that's great. So thanks for the overview. Good to see you again.
Thank you very much.
Yeah, and folks, stay tuned. We've got a couple more episodes coming up as we wrap up Chill Off 2, if you can believe it or not, and have some results posted here in the next month or so. So stay tuned. Thanks.